everyone. Good evening. This is Perspectives, a thought-led initiative by Kivani. Today, we'll be talking about lab safety and lab design. The old-fashioned idea that a typical lab comprises 4 walls and door has long since passed. So, what has changed? To answer that question, we have with us today Michael Blaney, PhD. Michael will reflect upon his decades of experience in improving laboratory safety by leveraging modern design. Michael serves as the Executive Director of the Office for Research Safety at Northwestern University since 2012. He has over 37 years of experience as an academic safety and health advisor. Michael has also published several peer-reviewed articles, book chapters, and produced many multimedia training programs. Michael's work has received recognition from professional societies and government agencies. Michael is currently the founding chair of the Safety Training Consortium, a project organized to create common laboratory safety courses by the University of California's Center for Laboratory Safety. Most recently, he served as an associate editor for the American Chemical Society journal, ACS Chemical Health and Safety. So that's a long and illustrious career and qualification Michael has held. We're very pleased to have Michael with us today. Before I turn the stage to Michael, just a little housekeeping. Please stay on mute and don't raise your hands during the presentation. If you have any questions in your mind during the presentation, you will see a Q&A box in your Zoom control panel. I repeat, the Q&A box in your Zoom control panel. Once the presentation is over, I will bring up your questions during the dedicated Q&A session. Now let's turn our attention to the speaker who is joining us from Chicago, USA. Well, it's worth mentioning that it's 4:30 in the morning for Michael, and we cannot thank him enough for getting out of the bed in the cold weather and sharing his knowledge with us. Michael, thank you so much for joining, and it's a great pleasure to have you with us today. The stage is all yours.
Thank you very much, Vijay, and thank you for being such a gracious host. Good morning, everyone. This is exciting for me because I've not had a chance to present worldwide in this way, so I've been excited to do this and got up early, and I've had my coffee, although the sun is still not up. So it's quite cold outside, but that's typical of Chicago at this time of the year. So thank you for the invitation, and thank you all for being on line today. My attempt today is to keep things high level, keep them conceptual, and really focus on process. Process and engagement are really the themes that I'd like to stress today. As we go through as we go through the topics today, anything that piques your interest or you find useful, please build upon those ideas. If there's anything that I present that's new or novel and you want to develop in some way, please just, I would be grateful if you would cite it as personal communication. But I love to share ideas. Safety is really something that can't be monetarized when it comes to concepts, and so I really want to share all that I can and anything that's useful to you. I also want to thank you to everyone who's listening from around the world and those who may view it in the future, to recognize that those of us involved in higher education, involved in science, help make the world a better place. And activities like this are important. There's no greater joy in my career than seeing the training of scientists and the work that they go on to do around the world. And although we all may come from different places and speak different languages, science is a culture of its own that unites us, and it unites us in ways that makes the world more peaceful and just. And I want to thank you for being one of those members of that community. So here are our topics of discussion. I promise I will not read to you the slides. I'd rather offer some notes and things. And I've made a few notes to myself here so I don't forget key things that I'd like you to know about. But if you draw your attention to the last item there, the real gist of what I'd like to cover is planning for the success of the project and the long-term viability of the future. Each one of us in these projects bring different interests, perspectives to the table, but taking a longer term view and seeing the building as a living entity, seeing the building as a space that's going to be modified and changed over time, is a very important consideration in lab design. Designing for flexibility are key items that I'd also like to stress again today too. I'm obligated, since I work at Northwestern, to tell you a little bit about our school. Northwestern is located in the great state of Illinois, and we are a university with 2 campuses. I'm speaking to you, as shown by the red arrow, from Evanston, and approximately 12 miles, 20 kilometers or so to the south of us is our wonderful and world famous medical school, and our law school is down there as well. So we're 2 campuses. I'm responsible for health and safety on both campuses. So we have 2 offices, a common name, but culturally the 2 campuses are very different. Most research goes on the Chicago campus. That's where our medical school is. Most of the high-end work, and for the last 10 years, I've lived here on the Chicago campus because here's where our chemistry and engineering departments are. We're sometimes called the third coast in America. You have the East Coast, the West Coast, and then the third coast. And we have this amazing piece of geology here, the Great Lakes. We're at the south end of Lake Michigan. Many friends of mine who've come from around the world look at that and say, that's no lake, that's a sea, that's a small ocean. And in fact, they're all navigable as well. But that's a critical part of America and a very beautiful part of America. So I hope if you've not been here that one day you'll come here and we'll have a chance to meet. So 2 campuses. You can look to the south here. You'll see that along the lakeshore of the Evanston campus, our students will paint the rocks occasionally. But down there with all those tall buildings is the Chicago campus. And we're known here on the Evanston campus, a symbol of our campus is the iconic Weber Arch, named for one of our presidents. And each year, the undergraduates, the 4-year students, the freshmen walk through that, the first-year students walk through that arch in a symbolic entry into their college education. Science at Northwestern is remarkable, and we'll talk about science in the context of laboratory design in a couple of different ways in just a moment. But I love historical pictures. I'll show you some historical pictures today. But we have a very prestigious chemistry department. Depending on who you ask, it's the 2nd or 3rd highest ranked chemistry department in the world. We currently have 1 Nobel laureate on the campus. And so science is a very powerful part of our experience here. But I'd also like to say too that the arts are very important at Northwestern. Many famous comedians and actors and actresses have graduated from Northwestern. So we're a very well-rounded school, but a very ascendant school. In America, we're referred to as R1 or a top-tier research institution. And in the decade that I've been here, we continue to ascend higher into the research ranks. And a lot of the growth that we've experienced that I have had a chance to see and participate in really centers around science. Northwestern today, there's a catchphrase that the university likes to use. It's one that I think is very true. We're now looking at the Chicago campus, that Northwestern is a world-class university in a world-class city. And the university, we see the Ward building there, which is actually a famous piece of architecture from the 1930s, surrounded by the Northwestern Memorial Hospital System and its affiliates. So we're like brother and sister when it comes to understanding how we work with one another, but we're separate legal entities, obviously joined by our medical school, and many physician scientists cross the line between patient care and basic science research. So when you think of research at Northwestern, most of our research, most of our laboratories are located on the Chicago campus. Now, my office, Research Safety, again, is one program that has to meet the needs of two different campuses as well. And feel free to check out our website as well. But we're a service organization. There are 25 of us. We have a contracted hazardous waste program, which is embedded within our program. What that means is that the hazardous waste contractors work with us every day. We share space together. We share lunch together, we work together. Been a very effective service model for our university and minimizing risk for the university as well. One of the things that is common for those of you that are safety advisors, but it's important to point out in the context of the work that we do, is every year we see between 25 and 30% new folks. Graduate students come, they graduate, postdoctoral fellows come, 2-4 years sometimes, they leave. There's a consistent base of staff and faculty, of course, but we're always needing to prepare ourselves to train, retrain, and continue that constant process of re-indoctrination as we evolve to support research safety. With that said, and it's a major academic interest of mine, teaching and learning is very important when we think about health and safety as well. We have about 6,000 lab personnel. It's more if you count them in different ways, but I want to give you what would be a fair and accurate number, and about 600 principal investigators. So principal investigators under our definition are in fact tenure track faculty. So you may get a grant as a postdoctoral fellow or a visiting fellow or bring some money with you as a visiting scholar, but you wouldn't be considered a principal investigator, which means that we have about 6,000 lab personnel involved in basic science research. So it's a significant portfolio for us to look at and manage, and charted over time, you can see that ever ascendant growth that we've experienced. Now, just one philosophical pause here as well. Compliance is a critical part of all research safety portfolios, all health and safety portfolios. We take it a step further. Compliance, of course, is important with government rules, forgive me, and regulations. However, we also spend a great deal of time here studying accidents and injuries associated with our scientists. Being a large school, being a school with a substantial endowment, we are interested because we self-insure our risk in looking at accidents and injuries. We published a paper a couple of years ago looking at accidents and injuries and found that for injuries that were frequent and could be we could design interventions for, hand injuries were a significant issue. So I'd like you to know that part of our orientation is not just ensuring that we've got compliance, but actually then targeting potential injuries and working to reduce the incidence, frequency, and severity of those injuries. And we've seen some significant process on that. So it's more than just compliance. We're interested in safety performance. Just a little bit about me. I'm actually from the Midwest. My parents are from Iowa. They grew up in rural areas. In the 1960s, my father, who was first to go to university, moved to Birmingham, Alabama, where he was a hospital administrator. My own education, it spread out over a little bit of time. I did have the great privilege of training in the Division of Safety at the National Institutes of Health in 1990 to 95 while I finished my PhD. Spent 17 years at Dartmouth College, which is a wonderful school. It's the smallest of the Ivy League schools. It's a tiny school in comparison when we think about research, but the great privilege of coming here and doing what I love the most, which is research safety. So world-class university in a world-class city. It's nice to be at Northwestern. All right, so here's the purpose. So I would like to talk in broad terms about safety implications associated with space. So space and safety and human behavior are all closely interrelated factors. All of us as health and safety practitioners, those of you that are engineers, those of you that are involved in building design issues, understand that engineering controls and the ability to control hazards at their source is perhaps the most critical part of protecting individuals. But there's another part. no sooner do we design a new building than people want to begin to change it. It's inevitable. I've seen it in every single building we've got. Oh, gee, well, if we could do this or we could do that as well. That has significant implications. So I encourage all of you, plan for that. Don't be disappointed by it, but understand that no sooner does somebody get into a space than they'll want to begin to change it. And that planning for flexibility makes it easier than to plan for and manage safety. And I'll try to give you some ideas as we go along today that I hope that you can use. So in preparing this lecture, I'm going through all my slides. I found this one actually from my dissertation defense, which was in 1995. This is my original idea. And these were the things that I saw early in my career that were issues that would limit safety management. Design of facilities obviously is part of that. In many cases, though, the design of the facilities, once it's up and running, is really out of our hands. Renovations may be a little bit differently. And I was surprised when I found this, completely forgot about it, that, gee, gosh, a lot of these things really remain true. And so I'd like to explore that a little bit in the context of things I share with you today. So do hold on to those things you write down from long ago, because at some point you may surprise yourself. So local exhaust ventilation, I like to start with that because movement of air is really the critical factor in safety in science and building design. Now, this system that you see here from somewhere between the 60s and 70s into the early 80s, one may look at and say, oh, well, that's really old. I don't want to leave you with the impression today that new is necessarily better. Older systems, and I realize that many of you will have older systems, properly maintained, work conditions properly evaluated, behavior properly directed, is perfectly fine. What we see today, however, though, is the opportunity to do more in designing for sustainability. And that has a lot to do, as you all understand, with heat recovery and making more efficient use of the space. It was very common in my early training as a health and safety practitioner. It was even a dogma that you got to have 10 to 15 air changes in a lab, no matter what, that was a prerequisite. Needless to say, that can lead to a tremendous amount of wasted energy. So I don't want to leave you with the idea that new is somehow better. In higher education, there is an enormous propensity to want to build new. Presidents, administrators, fundraising, get your name on a building, so on and so forth. So there's a lot of emphasis on that. But for those of us that do the work of the institution, we must, of course, maintain it. So at the outset, new isn't necessarily better, but that the key starting point in planning for safe laboratory design, in almost all cases, has a lot to do with ventilation. Now, here's an example of a building project where they didn't design adequately for air supply in the building. The building was starved, and at enormous expense, essentially doubling the cost of a building project. They had to then put in, and this has happened in many cases that I'm aware of, where they've had to put in auxiliary supply air, other ways of getting air to be able to ensure that the building wasn't starved of air and that you had sufficient air for makeup and so on and so forth. That, in many cases, those sorts of flaws, big flaws, can be extremely expensive. Now, design's one thing, but behavior's another. This is a collection picture of, from my slide collection long ago. This was a room filled with chemicals, and they were not all compatible. You can see they were alphabetized here, which makes them convenient to find. But poor behavior, bad management can lead to also very expensive issues associated with laboratory safety and management. And so then that idea that I suggested earlier of plan for storage, have flexibility, is really super important. In fact, 10 to 20% additional capacity or flexibility for that capacity is a rule of thumb that I'd encourage you to think about. Now you take bad space and bad behavior. Here we see some design casework from the 70s. They can't restrain the gas cylinder properly. They've got stuff all over the place. Then I think you set up, at least in my mind, the perfect storm for safety management problems. And here's where we have an opportunity to say, how can we design this space better? And then how can the safety management program, being part of that, then help think about management going forward, because the space itself will not take care of itself. That's a human issue. And so then you have to look at how are we managing the space and the people associated with it. None of this is new. This cartoon I found from the 1970s, right? And nasty chemical, and they don't have the right engineering controls. So the poor office worker or scientist is then left to wear a breathing unit as well. And it certainly looks silly and funny and so on, but there's a lot of ironic truth, if you will, in a picture like this that you can, in fact, think about and design for safety. So, as VJ said, the theme that we were talking about was four walls, no more, or no more, which really is things to think about in the lab design process. And that's why, since all labs are not created equally and science may have commonality, there are in fact differences in what people do, is really part of a dynamic process. I found this fascinating picture here from science, when science was largely a guild. For many, many years, early chemists were called pharmacists. They were involved in compounding. This picture I find fascinating because you'll see that they're aware of the need to vent out some of their hazardous materials. They're also using gravity for storage and then feeding various places as well. So we've come a long way since then, but that can at least be a starting point to think about. As humans, we're curious creatures. We are inquisitive. We want to know about nature and phenomena. So we go find things to help us understand those phenomena. Some of them may be hazardous, and then we build facilities and we start experimenting and trying to understand the secrets of nature. I'd like for our discussion today, however, though, to please focus your attention on the mid-20th century. And with the discovery of DNA, and especially in modern science like we do here at Northwestern, organic chemistry is really where I'd like our discussion to begin. That's where we see sort of the commercialization of science. We see the explosion in the United States and around the world in academic science, the creation of research institutions, and that science has actually become a very large economic driver in many communities, and we all enjoy both the benefits and in some cases the downside of that as well. I'm old enough, 61 years old now, I'm old enough to know and have seen and participated in some of the earliest open concept design labs. There's a lot of enthusiasm for this. It's, we can open the space up, we can break the walls down. Walls, like fences, sometimes make good neighbors. The reception for this concept and approach was not necessarily widely embraced in the beginning. And I'd like to point out, too, that there were limitations in how some of this space was designed, especially because there was inadequate office space or relief space in the design of these. Here we see the flexibility. So a lot of nice things, utilities from the ceiling, flexible casework, a lot of the things that our host is involved in today, which is fantastic. But by and large, in the early development of open concept labs, not enough space for the graduate students, tiny lunchrooms, no real place to sit down and brainstorm, decompress. And so we've seen, though, that design engineers, we see our host, we see a lot of different companies involved in improving those designs as well. So we've come a long way. And this is, in fact, now really the general design, particularly in biomedical and biotechnology, to look at open concept laboratories. Safety management is sometimes challenged. I know that in my time at Dartmouth, my colleagues and I ended up putting little numbers on each table because referencing where you found or saw something or who owned what was a little difficult. And so you had to rely on some other system. But now we have even more amazing designs, and that's the common standard here as well. Let's stop for a moment and think about what drives a lot of design requirements in laboratories today. Well, if we go back to prior to the mid-20th century, I don't think any scientist had any idea of how dependent we would become upon electrical equipment. We measured pressure with mercury gauges. We didn't have nearly the power demands that we have now. In many older science buildings, you will find, certainly on my campus, some of the older ones, are largely starved for power. And I'm using that term loosely. What I'm saying is that we've had to bring power into those buildings to meet the drivers of automation and high-end heating and ventilation and cooling. My suggestion to you is to plan for capacity. Very expensive, as you all would know, to bring in large amounts of power. Planning for capacity, planning for that flexibility is very important, driven by automation. The pace of obsolescence in scientific equipment in my career has only increased dramatically, where pieces of equipment are very popular and everybody wants to play with it for a period of time until something new and better comes along. From a management perspective, we found ourselves needing to find relief space to store all this stuff that may become obsolete, and then bring new equipment in and make new installs. So planning for that flexibility is also very important. State of the art, well, Kwani and others and many of you are designing what's going to be the state of the art. But in all cases, like artists, this will be a creative space. Artists and scientists are similar in the sense that they need and will create for themselves spaces to do their work. They need to be safe spaces, whether they're artists or scientists as well. But the idea of science and creativity are very important together. So we're looking holistically at the design of facilities, not just, oh yeah, we can give you a bench. Oh yeah, this is what it's going to look like. I'd also like to point out too that the roles that all of you will play are very, very essential. Space design and building is very political in any type of organization as well. People will worry about budgets and so on. The opportunity I think we have as safety practitioners, as building engineers, as people interested in science and science design, is to think about it more holistically. What are the needs of the science that we're going to be doing, and what are we going to be able to do to design for flexibility? Just want to set a couple things aside. Critical environments like clean rooms. I've been involved in projects where you try to squeeze a clean room into an existing space. I'm sure some of you have had to deal with that. Enormously expensive to do that. Where you can build purpose-built dedicated facilities for critical environments, you're by far and away better off. That being said, the involvement of those that have to maintain the building, those that have to provide safety services to it, is a critical voice early on. Here's an example. We have a brand new, beautiful clean room. They wanted to make it a showpiece for the university. They put it on the 4th floor of a building, but then we ran into issues with code requirements. How much flammable material could we have at what elevation in the building? And it led to some expensive reconsideration and redesign. Everything worked out fine in the end. Having those conversations earlier would have been helpful for both the scientists and the project budget. Animal care facilities, again, highly specialized facilities, and they carry the additional requirement for physical security because of sensitivities of animal research. So I just wanted to cover those and dispense with them in general terms. Designing for support areas. Concept I'd like to leave you with. Think about how materials come in to the building. So if you step back and you don't rush right to design, if you start with the loading dock, right? If the heart that keeps the building beating is in the ventilation and the utilities and all those things our great facility staff have to look at, then the lifeblood of the building is going to be materials management and materials transport. Think about those support areas. It's very common for support areas to get short shrift because people are starved for space. Oh, geez, we forgot where we're going to put the hazardous waste, folks. We forgot where we're going to offload materials. We forgot about in training, fumes from trucks because they need to idle or they're idling on a cold day. All of those discussions are critical in the beginning. And if you expand the circle of your design concept, thinking about support areas, you come out much, much further ahead. Sustainable energy use, as I said earlier, old school, the idea that 15 air changes no matter what. Tremendous power demands, as you all know, in modern building design, in any building design, new or otherwise. But I am a person that embraced very early on, for practical reasons and for reasons of the environment, heat exchangers. What can you do to recover without compromising worker health and safety, but also conserve energy? And certainly in ultra-modern designs, you have occupancy sensors, proximity sensors, timers, and other things, more things to maintain and pay for, worry about, but you can create a much more sustainable footprint for the building, thinking about energy use. So that's money and time well spent. So some ideas to consider. And I think I'm doing fine for time now. This is really where I wanted to give you some ideas that I think are important, and certainly some ideas that I'd love to see developed into the future. Now, all too often, it's easy to forget, and I'll just show this video to you. It's easy to forget that real people do real work. And when designing a building, as part of the needs assessment, I encourage everybody to go talk to the scientists, as we're doing here, to go observe them, to chat with them, learn about learn about the work that they're doing, understand their needs and frustrations in the process of doing science, and that will help better inform the conversation as well. You'll clearly be given specifications. A building needs to look like this. It needs to cost no more than that. But I found time and time again, just the short investment and the goodwill that's earned from going to these locations, talking to folks, say, hey, what are you doing? What do you need? What are you lacking? What can we help with? And inevitably, from the work that I do as a safety advisors, we need a little bit better storage. We need a little bit better standardization. That same concept applies to with the facilities folks. I have seen in this institution that eye wash stations come in all shapes and sizes. And if you talk to the plumbers, the first thing they'll say is, I can't maintain these things easily because nothing's standardized, right? We've got trundle bed eye washes, we've got sink eye washes. And so we've worked hard here in the time that I've been at Northwestern to develop, and this is not a new idea. These are sort of performance tear sheets that we adapted from looking at public documents, NIH documents, Department of Energy documents, to give performance criteria for the space, but to emphasize the fact like standard eye wash station, standard design cabinetry, the very predictability that we see in modern casework design from Kiwani and others, that gives us the modularity and the flexibility then for maintenance personnel to take care of it. Even silly little things like clips in flammable storage cabinets, corrosive cabinets, which may rust and fall apart, can become a real sticking point when it comes to repairing and maintaining the building. So learn from scientists, learn from facilities person. The other thing that we've learned too in the process is to take a critical eye at looking at the spaces that we're going to design. It's very easy to get caught up in sort of rushing to who's going to get what space or what are the finishes going to be on the walls, to look at the actual potential risk in the areas. Risk in a biomedical environment is significantly different than risk in a chemistry or engineering environment. Do you really need that safety shower down the hall for a lower risk environment, or would a suitable standardized drench hose safety certified unit, either to a UN, EN standard or to an American standard, would that be sufficient? Those are informed conversations. We've seen this to be especially valuable in our work in renovations of spaces. So when we renovated a machine shop not too far from where I'm speaking to you right now, we didn't need safety showers there in anymore. We needed an eye wash because of cutting fluids and other things. But we were able to save hundreds of thousands of dollars in not replacing what were otherwise eye wash stations that had been put in there long ago and far away for good reasons. But we used a risk-based approach to really look at the materials, the processes. Again, these are spaces that are going to have large fixed machines in that, so they wouldn't change significantly over time. A risk-based approach is time and money well spent. I've mentioned it before, I'll mention it again, designing for flexibility as well. In some universities in America, and perhaps for wherever you might find yourself, space is readily available. We see that in large state institutions, so they just go and build something new. That's very difficult in an urban environment, very difficult in the environments that I'm working in now, because we really don't have convenient relief space. We don't have a place to move space is either being built or renovated. But within the context of design now, think about relief space. Think about where and how you will have space for the things that you need. And wherever possible, particularly working with your safety engineers, design out those things which may be architecturally appealing, but may be difficult, confined spaces, fall hazards, and so on. Again, life cycle planning for the building and ease of maintenance over time. I really couldn't find a better picture of this, so forgive me, I'm using an office type environment. We've made some progress on this. Many labs will have a large mushroom button, which would kill power to the space, interrupt power as well. But I'm very interested in the modern design of integrated controls for signaling. So you would have fire alarm information there, you would have warning information there, you'd have the ability to shut power down if that was a critical application, but to have flexible controls associated with the space that are useful. I'd like to caution you though, I have seen particularly buildings in the 90s now where the ability to put automated controls and sensors in became sort of an addiction. People were beginning to put all sorts of sampling devices and sensors and controls all over the building, and without any real thought that a human being had to look at these alarms when they came in and to determine whether they were real, whether it was a problem, what they needed to do. And in many cases, humidity monitors were a good example. Folks began to just not pay attention to them. So you have to think practically about what is the application, what do you need to know, what's critical, and so on. Again, to be very positive about this, many of those things are beginning to be addressed out through modern design and the constant feedback that engineers are looking for to design better systems. But what's the purpose of it? And is it a useful application for your particular needs? As I said earlier, in the development of Open Concepts Lab, too little space was allocated for creative space. That's really changed a lot now. There's a premium, particularly in our most recent building. We have a beautiful building downtown called the Simpson Query Building, two very generous people that contributed to the University in Biomedical Sciences. And it has what I would describe a high livability factor. The labs are on the inside. The offices are all on the outside. There are large, open, comfortable common workspace areas for graduate students and others. They can enjoy their lunch, their coffee, they can wash their hands before they leave. There's automated doors and so on. But we're not trying to put the poor graduate students into a small space with a little, a little writing surface there, and they're trying to hide their coffee cup when the safety folks come around. So creative space is really important, and I'd like to see that trend continue over time. Now, big idea right now. Talked about the Simpson Query building. Amazing building, totally amazing building. But imagine now if we were to take all of the documentation to create a virtual history and record, right? A virtual record that could live into the future, adapt to new data recording systems, right? But it would literally be a living repository of design documents, as-built, maintenance records, and all of the other essential information. All of us know building engineers, you go in and bless their hearts, they know where to look for the piece of paper, but it's just stacked full of papers. And when those people leave and when those people retire, you just simply don't have the ability to download all that information. It's gone with them. And creating virtual histories and a repository, to me, for those of you that are involved in design or will be making requests for design as part of the deliverables, to me seems like an incredibly exciting idea. And as we finish up today, this is what I see particularly to draw all these different ideas together, which is the idea that you would be able to prepare those that will live and work in the building with a tutorial, like, welcome to your building. Here's how we're using occupancy sensors. Here's how we have fume hood controls in place. Here are the things that we need you to do. Here are the things that we not need you to do. But if you could envision that as being part of the handoff, so I'm really speaking to design firms now, that is an amazing value-added proposition, that you're not just delivering a building, you're delivering a blueprint for how you would use the building, how you would enjoy the building, and prepare people for life in the building rather than, I wonder what they did over here. Again, part of the continuity, thinking about the building for really what it is, which is a living, breathing, dynamic environment and not just four walls. Expanding the circle has been a major theme that I've talked about to now as I end, getting those conversations started, getting people involved. You can't please everybody. We all know that. There are real budgets, there are real decisions that have to be made, there are real politics associated with it. But it has been my experience over many years, if people are given a voice to express their opinion, they then become invested in the outcome. Even if you can't make everybody happy, you've at least shown the deference to them and given them the respect that they need to feel like they're part of this building as well. And many, many benefits come from that as well. So I really appreciate this opportunity to talk to you. I really want to thank Vijay and Kwani for inviting me as well. If you'll let me just mention one other thing here. Vijay talked about it at the beginning. A project that I'm very proud of that I helped lead with colleagues at UCLA, University of California, Los Angeles. We have a training consortium. We'd love to have members from around the world. We've been developing basic fundamental training. Good practice is good practice, no matter where you are in the world, no matter what rules and regulations you have as well. And we're building a small portfolio. I'm very excited to say that our second version of our lab safety fundamentals course is coming out. We have them in biosafety and radiation safety as well. But these are courses which are built to common IT design standards that can be adapted and customized by various schools. We share resources. We contribute a little money every year to help build and hire highly talented people to help with. So that's my sales pitch there. If there's anything that interests you about that, please reach out to me. And please, if there's anything interesting or useful or thought-inspiring that I've shared today, please take it and run with it, and don't hesitate to reach out to me. I'll stop my share now, Vijay.
Thank you
Thanks,
very
everybody.
much.
Yeah, thanks everybody.
Wonderful. Thank you. Thank you, Michael. So build a space where you don't have to hide the coffee cup. Anyway, so jokes apart, my key takeaway is that improvements in the laboratory safety cannot be looked at in isolation. It's an amalgamation of lab design, aesthetics, and dramatic changes in the building engineering. Of course, it comes with the caveat that new is not necessarily good.
Right,
With that
thank you.
said, questions have started coming in from the audience. So let's segue into the Q&A session.
Please
If
do.
you have any questions, please put it in the Q&A box. Okay, along with the questions, there are a lot of thank yous and compliments for you, Michael. Thank you so
Thank
much.
you.
Okay,
Thank you
let's
all.
go to the first question. That's from Satyamurthy. The question is, are there any fire codes or standards depending upon the type of laboratories? Specifically for chemistry facilities, is there a fire rating for fume hood and electrical fittings?
Yes, absolutely there are. Now, in America, what's a funny term, the jurisdiction having authority is your local fire service. I am speaking to you from Evanston, which is a city of about 70,000 people. I can drive 2 miles and I'm going to be in the city of Chicago with millions of people. Different but similar, right? Fire codes apply, and it's really that local jurisdiction having authority. In the absence of that, though, I think most of us would agree that in America, you would turn to the National Fire Protection Association for that as well. An underlying element to that, though, which I'd like to remind you all, is that by designing for capacity, and this was a challenge I had when I first came to Northwestern, to get folks to have what they will reasonably use for chemical throughput over a 3 to 6 month period, sometimes less than that if they're a high throughput lab. We have some laboratories who will pick up to 20 to 30 gallons of halogenated or non-halogenated waste a week. They're big synthetic laboratories. to get their stock inventory at or below what would, and to get them into flammable storage cabinets so that in the event of a fire, it doesn't overwhelm the sprinkler or fire suppression system. And I realize some of you may not have those, but part of that challenge is then ensuring that there are enough rated flammable storage cabinets that in the event of a fire, all those additional BTUs aren't going to exacerbate the fire.
So I'll pick up a popular question from Rifki Rianto. Thank you, Michael. Could you please share us your experience in lab waste management regarding the safety?
Yeah, I like to use a term that's used by actors and theater people called back of the house. So back of the house is all those things you can't see from the stage. Hazardous waste is a major back of the house activity for us. Sometimes administrators think that that's all we do. It's certainly a major part of our budget, but designing for a facility to safely accept, store, and segregate and store hazardous waste is critical to protecting the building or protecting the environment, protecting other individuals. So in our situation, those spaces are typically at ground level in proximity to the loading dock so that we minimize the distance we need to transport. We're also able to keep those materials out of common public spaces as well. And I would certainly be happy to, separately, anybody wanting to look at some of our design features. When I was at Dartmouth long ago, they had actually built a dedicated building into the side of a hill. It was like a large bunker specifically for that purpose. that also definitely needs ventilation and probably some intrinsically safe lighting.
Okay, moving on to the next one. There are a lot of questions from Vinod Bhagat. I'm going to pick up two in the interest of time and to give an opportunity for other questions. So this is about storing in fume hood. I'm clubbing two questions together.
Yep.
Is it safe to keep cylinders in fume hood to do the experiment? If not, where would you suggest that the cylinders be kept? And also, is it storing chemicals below the fume hood is safe? So is it safe to have cylinders and chemicals stored below the fume hood? That's
the answer is yes. The answer is yes. So our standard design for a fume hood now is typically a 4 or 6 foot hood, and whatever the metric equivalent would be. And in the base cabinet, we would have a rated flammable storage cabinet on one side, and then we would have a corrosives cabinet on the other. If that's not possible, one side would be dedicated for flammable materials and using plastic bins or trays to further segregate them, and then use the other side for corrosives. Keeping volumes down is essential to that. The idea of using smaller gas cylinders in a fume hood is very important. If you don't have that and you're using larger bottles, then you have to think of the additional expense and engineering control associated with a toxic gas cabinet. Those sorts of cabinets, of course, are essential in modern clean room designs where toxic gases are used. But the answer is very much yes. You know, as much as you can, keep it inside the hood. And that's a key part of our curriculum is when you work with hazardous materials, work with them inside of a fume hood. And when you can't, that's where you need to talk to your safety advisor to make other arrangements, because you obviously don't have a means of control if there's a release or a spill.
all right. So from backyard, we'll move to basement. This is a question from Anupama Sharma. What should be the precautions, or what are the precautions required for a chemical laboratory planned in a basement?
Great question, and we have faced that question many times. I'm on the ground level right now in what's called the Technology Institute. It's a sort of famous building in science buildings in America. First and foremost, remember that egress may be difficult out of spaces like that. So you do want to show good judgment in placing appropriate science in those basements. It's going to be very difficult to use large quantities of materials in basement areas. That space could become unsafe very quickly. What we have found here is that many of our basement spaces have been better served because they're right on the foundation for laser tables and other things which are sensitive to vibration. But that is a good question. It's not impossible, but you really do need to have that conversation with your local authorities in terms of what's going to be acceptable. The other part that I'd like to strongly emphasize is work closely with your local first responders. They need to know that that's there because they will be the ones that will have to potentially risk their lives and go into those spaces.
The next question is from Sujarvo Suryaputra. The question is, for a research lab, how often is the audit required for safety implementation?
Great question. Great question. So over the years, I have evolved into a tiered approach. So for all our synthetic chemistry labs, and I have a wonderful young early career PhD, he's going to be a great leader. He's proving himself every day now, Dr. Ben Williams. We look at our chemistry labs thoroughly for a lab safety review of performance-based audit twice a year. For general laboratories, and those could be some engineering labs, depending on the work they do. It could be some biomedical labs. Typically, the lab safety review will happen within 12 to 15 months. It's not unreasonable, though, because we're always taxed for time. We have some biomedical environments, some medical school environments, some basic science environments where the work is of such a low risk, or the lab is so impeccably run, so we also give credit for that, that we may expand that inspection schedule to 18 to 24 months. We have a recognition program, and we'll start another cycle as we come out of the pandemic, of recognizing high performance labs, those labs which are typically there's a matriarch or a patriarch looking after the lab, where they do such a good job, and we have so few problems with them that we give them a plaque on the outside of the lab, and we inspect them on a less frequent basis because we never really have to worry about what they're up to. So a one-size-fits-all approach is not necessary, and again, use a risk-based approach for the work that you do to help decide how often an appropriate schedule would be.
Fantastic. The next question is from VHH Kumar. This question is, would you recommend ductless fume hoods with suitable filters because they are highly energy efficient when compared to a conventional fume hood with external exhaust?
Early in my career, I was trained at the National Institutes of Health, and the National Institutes of Health takes a very strong position to avoid ductless fume hoods. Ductless fume hoods are, they look very nice in a catalog. You look at them, you think, oh, this will solve all my problems. One of these things there. They're not the magical system that they portray themselves to be. If you were doing sort of simple water chemistry for boilers or something, yeah, I'd be okay with that. I had a situation where a very nice young assistant professor wanted to do a lot of histology staining in those neat little slide vessels, and everybody was upset about the smell of xylene. So I would strongly discourage you from using those devices, except if you can very narrowly define them. May I also say too that you will not see with those devices, and they won't mention it in the advertising, but at least in North America, the National Sanitation Foundation, and I don't know what the EU equivalent is, they do not certify those devices as for chemical containment.
Audience choice question from Abdul Bari. Is there any international body or safety audit committee that can certify a lab? And the second part of the question is there anything specifically available in the Middle East and Saudi Arabia? I'm not sure if you can speak for the Middle East. The first part is about, is there an international body?
That's a really fascinating question, and really the answer is no. Now, so let me try to think a little bit out loud. The idea of doing that is a good idea. We have professional organizations that will certify for energy. We have professional organizations that will certify for animal care and use programs. But to the best of my knowledge, there's not one that would, essentially look holistically at the building. That may be a very wonderful idea to begin to explore. Now, that being said, I don't think it would be impossible to get, because I know there's a lot of subject matter experts on this call, to get sort of the right group of people to be able to look at and provide recommendations on performance, knowing that everybody's different, everybody's got a different building. One of the things I'd hate to see in doing that is setting people up for failure. That goes back to my initial statement, which is, new is better. There are plenty of building environments I've seen where they're well maintained. The mechanical spaces are clean. The facilities people are fiercely proud of how hard they work. They keep wonderful preventive maintenance records. And you'd want to give credit to those buildings rather than saying, well, gee, it's not like brand new or something. So that's a great idea. And I think that one is one that should be further explored. And if you want to reach out to me, I'd love to work on that idea.
Brilliant. There's something in it for everyone here. So in the interest of time, last question from Sanjeev Kumar. Please highlight management of biomedical waste.
Yeah. So that's a big challenge, I think, around the world. And I'll just tell you a quick story here. We actually calculated the, well, in America, we have one company, I won't mention them, but they're like the big company, right? We sometimes call them the evil empire. They have like the largest set of market share, but their approach to waste management either is to burn it, right, which has significant environmental implications, or to high temperature autoclave it and then just dump it in a landfill. We, as part of our rebidding our hazardous waste contract, right, so we were working with the vendor, we stated at the outset when we put all of our waste under a single contract, so different brokers are helping a single contractor manage our radioactive waste, which is different than our biomedical waste. We were very interested in what other technologies would be available. The technology that we settled on was a large rotary autoclave that then shredded, I mean, tremendous machines here, cutting machines, then shredded the waste, rendering it and using magnets to pull the metal out so the needles and everything came out as well, using that then so that it could then be put into a conventional landfill without any additional requirements. In the case of the large vendor that I was describing there, and you know, they're a good company, but they also are very dominant in the way they control the market. We were trucking that waste several hours away from Chicago. So when you sat down and did the carbon footprint, it was not particularly good. I will tell you that in the great state of New Hampshire, which is a very small state, that at Dartmouth, we used autoclaves both for, we would have a clean autoclave and then there would be typically a waste autoclave. We would use the autoclaves with a quality assurance process, primarily using spore vials to determine that the waste had cooked a lot. And then we would have to keep those records, but the waste then could be safely, as long as there were no other hazardous materials, taken to our local community landfill. So there are both high-tech and lower-tech approaches. I'll close by saying that here at Northwestern, we generate as much on a weight basis bio waste as we do chemical waste. And over the years ahead, we want to control the unfortunate behavior that biomedical scientists have of putting plastic wrappers, pipette wrappers in the bio bin, glove boxes, things which are not biohazardous, but they throw them in there as a matter of convenience. We want to reduce what I would call the non-conforming waste into that so that we can further shrink our environmental footprint. That's something that we can measure.
Okay, so with that, we'll bring this to a close. Michael, thank you very much.
Thank you so much. And
extremely insightful. Thank you.
Yeah, to all of you out there, greetings from Chicago. The sun's still not up, but if you have any questions, just look me up, write me, and I hope that we have an opportunity to meet in the future or work together on projects.
Absolutely, that'll be wonderful.
Have a great day.
There are still a few unanswered questions. I'll send them across to you.
Yeah,
and,
would you do that?
If you can give an offline response to those, we'll put it up on our website.
That's great. I'd love to do that. I don't want anybody to feel cut out of the process. So, all right, everybody, be well, and hoping for a better tomorrow as we get through this this pandemic. So everybody stay safe.
Better tomorrow it is. So thank you very much. Everyone, thank you for joining. We'll see you the next time. This
Thank
is
you.
Perspectives, a thought-led initiative by Kiwani.
Thank you all so much.
Bye-bye.
Bye,
Good
Vijay.
evening.
Bye-bye. Bye.
Bye, Mike.